Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the haloform reaction, a genuinely powerful tool for both identifying and synthesizing specific carbonyl compounds. Let's begin. The haloform reaction genuinely only works on compounds containing a methyl group directly attached to a carbonyl carbon, the specific CH3CO pattern. This includes methyl ketones directly, like acetone, and it also includes acetaldehyde itself, since acetaldehyde is genuinely the one aldehyde that happens to have this exact same CH3CO arrangement. It also genuinely extends to any alcohol that can be oxidized under the reaction conditions into the same methyl ketone pattern, specifically secondary alcohols of the form CH3CHO and ethanol itself, since ethanol first gets oxidized in situ to acetaldehyde before reacting further. Compounds lacking this specific CH3CO pattern, like propyaldehyde or dial ketone, simply cannot undergo the haloform reaction at all, no matter how vigorously you treat them. The reaction proceeds by treating the methyl ketone with a halogen, like iodine. In the presence of a base like sodium hydroxide, the base first removes an alpha hydrogen from the methyl group to form an enolate, which reacts with the halogen. And this halogenation step genuinely repeats 3 times in succession, since each successive halogenation makes the remaining alpha hydrogens on that same carbon progressively more acidic, due to the electron withdrawing effect of the halogens already present. Once all 3 hydrogens are replaced, the resulting CX3-CoA intermediate is attacked by hydroxide ion at the carbonyl carbon, and the resulting tetrahedral intermediate collapses by expelling the highly stabilized CX3- carbanion, called a trihalomthi ion, which is genuinely stabilized by the 3 electron withdrawing halogens. This trihalomthide ion then immediately grabs a proton from the reaction medium, forming the haloform, CHX3, chloroform, bromoform, or iodoform, while the rest of the original molecule becomes a carboxylate salt. The single most frequently tested application on the JEE is genuinely the iodoform test, specifically using iodine and sodium hydroxide, or equivalently sodium hypoiodide. A genuine positive test produces a bright yellow precipitate of iodoform, CHI3, with its own genuinely distinctive antiseptic smell, and this positive result is exactly diagnostic for the CH3CO pattern or the CH3CHO pattern being present in the tested compound. A frequently tested trap involves genuinely knowing exactly which common compounds give a positive iodoform test: ethanol, acetaldehyde, all methyl ketones, and secondary alcohols of the CH3CHO form, like propan 2 all give a positive test, while genuinely only compounds truly lacking that exact methyl adjacent pattern, like methanol, propan 1 all, or propanaldehyde, give a genuinely negative result. This test is also genuinely useful synthetically, since it provides a reliable, controlled method for shortening a carbon chain by exactly 1 carbon while simultaneously converting a methyl ketone into a carboxylic acid. Let's recap. The haloform reaction only works on compounds with the CH3CO pattern, methyl ketones, acetaldehyde, and alcohols that oxidize to this pattern. The mechanism involves 3 successive halogenations followed by cleavage, expelling a stabilized trihalomthide ion that becomes the haloform. The iodoform test using iodine and base gives a distinctive yellow precipitate and is the single most frequently tested JEE application, serving as a reliable diagnostic for this exact structural pattern. That's the haloform reaction. Keep the CH3CO structural requirement and the iodoform test as diagnostic power sharp. It's a guaranteed, fully tested identification question. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.